Good morning. Here is a linear motion free response question. So we have a velocity given and a initial position given, and we're going to answer these questions. So A, find all values of t that the speed is 2. So for A, the speed is the absolute value of the velocity. And this is a calculator question. So I've already set that up. I typed the velocity. Don't ask me why I didn't y2, but I did. The velocity is in y2. The speed is in y3 because I put the absolute value of the, oops, this is wrong, not y1. I want y2. So let me delete y1, alpha calc, y2. All right, so now I have the velocity in y2 and the speed in y3. Question I asked for the speed. So I'm going to turn off the velocity, and there's your speed. It says we need to figure out where the velocity is, the speed is 2. So I'm going to graph y equals 2, and then look for the points of intersection. So here's the answer. The absolute value must equal 2. It's a calculator question, so that's all I have to do. But also between 2 to 4 it says. So I'm going to take my calculator back here. Intersect. I'm going to pick the two graphs. There's only two, so enter. I'm going to go over. That's x equals 1, so I'm not going to use that one. Now I'm past 2, so my guess is there. And that's the answer, 3.127 or 3.128. So there was another one. So I'm going to do the same process. Second calc, intersect, enter. But now I'm going to scroll over to the next one, or closer to the next one. I got 3.473. I'm trying to show all the work you would need to show on the actual AP exam, and that's it. So I'm going to erase this. If you need to look at it longer, pause the video, because now I'm ready for question letter B. Write an integral expression that gives a position. So that's, you don't need a calculator for this one. Maybe for the next part you do. But the position is, you take the initial position, which is, what is it? At 0, it's 10. So we're starting at 10, and we're adding from t equals 0 to t equals whatever. So remember, all this is asking for is an expression that gives any position. So we're going from 0 to t. So whatever time, this would do it. And we're going to integrate the velocity, so it's net distance. Now, if you notice v, you can write v of t here. I don't think they would have a problem with it, but we're going to time t. So you don't really want to make this a t here. We're going to use the dummy variable x. So there you go. That would give you the final position at any time t. So it says the second part is use this expression to find the position at time equals 5. So we're just plug in 5. And then this is a calculator question. So I'm going to go to my calculator. I'm going to clear all this because I'm going to use the answer in my calculate screen. You'll see that in a second. I don't want total distance now. I don't want the absolute value. I want the velocity. I'm going to turn off everything else. So here's the velocity. I'm going to integrate this from 0 to 5. So that's my net change. And remember, I have to add this to 10. So I'm just going to go plus 10. I have negative 9.207. So I'll just write that down, negative 9.207. I'm done. So this was the first part of the question. This was the second part of the question. So now we'll go to question C. Again, if you need to look at this longer, pause. Find all the times that the particle changes directions and justify your answer. Well, let's justify the answer first. A particle only changes directions since velocity is direction when velocity changes from negative to positive or vice versa. So it's because the velocity changes from positive to negative or negative to positive. There's my justification point. And now I'm going to figure out when that happens. And that's very simple with the calculator. We already have velocity graphed. Let me clear all this stuff. Go to draw and clear draw. That takes care of all that shading from the integral. And again, we're going from, this question is from t equals 0 to 5, I believe. So we don't have to worry about the negative ones. So these intercepts are where the velocity changed direction. So second calc 0. The first one is between 0 and 1. So I'll go left bound 0, right bound 1. Enter for a guess. I got 0.536. I'm going to copy that down in a second. And then I'm going to take this one, which is between 3 and 4. So second calc 0, left bound 3, right bound 4. Enter for a guess. 3.318. So those are the answers. T equals 0.536 and 3.318. So I'm going to clear that and do question D. Question D, is the speed of the particle increasing or decreasing? So you have to remember that the speed is increasing when velocity and acceleration are the same sign, and decreasing when velocity and acceleration are different signs. That's the reason for my answer. So because V of t because V of 4 and A of 4 are or have different or the same sign. So now we have to figure that out. So we had to figure out what V of 4 is. V of 4. And then we have to figure out what A of 4 is. These are calculator questions. So very simple. The calculator, V of 4, this is the velocity, so second calc value at 4. Negative 11.476. a of 4. That's easy as well because we know a, the acceleration, is the derivative of the velocity. So second calc derivative, 6. At 4, bam, negative 22.295. So because they are the same sign, we can conclude that the speed, sorry about the mess, speed is increasing at time equals t equals 4 because velocity and acceleration have the same sign. And that is it. It's pretty simple. So thanks for watching.